Okay, fundamental theorem of algebra, unit 2, day 6. Let's do this. So if p of x is a polynomial of degree n is greater than or equal to 1 with complex coefficients, then p of x equals 0 has at least one complex root. Remember, complex means it has I in there. Okay, so p of x equals 3x cubed minus 2x plus 3 is a polynomial of degree 3, so p of x equals 0 has at least one complex root. That's the fundamental theorem of algebra. We'll go more through that in just a minute. Okay? So this is how to use it. We're just going to get straight into this. So basically all this is we're combining everything we've done this unit and we're putting it all to work. Okay? So first we have to find the roots of this equation. So we have x to the fourth plus 2x cubed equals 13x squared minus 10x. So I just need to get everything to one side. So I'm going to subtract the 13x squared and add the 10x. So I get x to the fourth plus 2x cubed minus 13x squared plus 10x equals 0. Okay. I can factor out an x from all of those. They all have the x in common, so I'm just going to factor that out. All right. That means we can set that little piece equal to 0. So then x equals 0, that is one of our roots. And here, this is to the fourth degree, which means there's 4 possible roots. So we just have to find the other 3 roots. Okay? So now I'm going to use the rational roots theorem. So we have to find p and q. Remember, p is the constant, q is the coefficient. So we're going to find the factors of p, plus or minus 1, 2, 5, and 10. And then q is just 1. So those are all of our possible factors. Okay, let me go back for a sec. Those are all the possible factors. So now I'm going to use synthetic division to try and figure out which one of these is a root. Because those are possible, we have to figure out which one really is. So use synthetic division, bring down the 1, multiply, add, 1 times 3 is 3, negative 13 plus 3 is negative 10, negative 10 plus 1 is negative 10, 0. So we lucked out, that is our root. So that means that x does equal 1. Okay? Now this is x squared plus 3x minus 10. Then we're just going to factor this. That factors down to x plus 5, x minus 2. So that's x equals negative 5 and x equals 2. We have all 4 roots there, so we're good. So we have x equals negative 5, x equals 0, x equals 1, x equals 2. That's all. We don't have to find the remaining roots because we already found all 4 of our roots. This was a fourth degree, which means there's 4 roots. Okay, so in this case, there wasn't any complex roots. Or technically these are complex roots, but we didn't have any with the I in them. Okay? Let's do one more example. So again, we're just going to find, everything's on one side. There's nothing we can factor out of here, so we just need to find what our possible roots are. Okay, so p equals 12, q equals 1. So then our possible list of possible roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Now I'm just going to do, okay, this is where I wanted to show you the 2 ways. So you can either do synthetic division, or you can just plug these roots in, and if you get 0 out, then that is a root. If you don't get 0 out, then it is not a root. Okay? So if I plug 1 in, plug that all into your calculator, you get 40. That is not a root. So I'm just going to ignore that one, go to negative 1. Maybe. I'm going to go to negative 1. Plug that in. I did get 0 that time. So that means that it is a factor. Negative 1 is a root. So x does equal negative 1. Now I can use synthetic division with the negative 1 because I know it's going to work. So I'm going to put those numbers in, 1, 4, 7, 16, 12. Negative 1 on the outside. Drop down your 1, multiply, add, get 3. 3 times negative 1 is negative 3. 7 plus negative 3 is 4. 4 times negative 1 is negative 4. 16 minus 4 is 12. 12 times negative 1 is negative 12, 0. Okay, so that ends up being x cubed plus 3x squared plus 4x plus 12. Now we could go through and do the rational roots theorem again. I have 4 terms here. So before I do that though, I'm just going to try factoring by grouping. Okay, so I'm going to group those first 2, and I'm going to group the second 2. Oops, I'm skipping ahead of myself. When I group those first 2 here, I can take out an x squared, and I'm left with x plus 3. When I group these second 2, I can take out a 4, and I'm left with x plus 3 again. So then I'm left with x squared plus 4, or yeah, x squared times x plus 3 plus 4 times x plus 3. So you can break those up. The x plus 3 gets pulled out, so that's its own parenthesis. X squared plus 4 is its own parenthesis. I'm just going to split these up, set them both equal to 0. And I'm going to solve. So the one on the right is easy to solve. It's just x equals negative 3. The one on the left is also easy to solve. We just have to solve it with the square root method. So we get x squared equals negative 4, which means x equals the square root of negative 4, which means x equals plus or minus 2i. So if we look here now, we have 1, 2, because 2i, negative 3, and negative 1. We have all 4 roots, so we're good. Okay? That's really all this is. It's just wrapping everything up. It's just using all the knowledge that we've gained throughout this unit, and we're just putting it all to the test, okay? So tomorrow is basically just going to be all this. Remember to take the quiz, and I will see you then.